Van de Graaff generator was invented by Robert Van de Graaff around 1930, used to charge particles in atomic accelerators. Nowadays, it used mostly to educate students about electrostatics. It can even make your stand on end in a dramatic display of static electricity. Well, see here how it works. The instrument features a small motor that makes a roller at the bottom of the machine start turning. That roller causes a belt to turn, which then causes a second roller at the top of the machine to turn. Two metal combs are positioned very close to the belt, one at the top, one at the bottom, and the whole thing is topped up by a large metal sphere. Although all Van de Graaff generators have these parts, they are not all made of the same materials and may work a little differently, but they all exploit the relative tendency of materials to lose or hold to negatively charged electrons. So now, spark your curiosity exploring the electrifying world of Van de Graaff generator. Let's pile a few balls made of aluminum foil on top of the bowl. When the Van de Graaff generator turns on, all of the balls will be charged, the same as the dome. The electrostatic repulsion will force the balls apart from each other, sending them flying one by one off the Van de Graaff generator.
There is enough heat in a candle flame to cause some charge separation. A Van de Graaff has the ability to make a candle's flame flicker when a flame is positioned close to the dome.
As you can see, the bulb would light up when exposed to the static electricity generated by the device. This is because the Van de Graaff generator creates a high voltage potential difference between two conductive surfaces, which can cause electrons to jump across the gap and flow through a circuit, such as the filament of a light bulb.
When we place a paper puncher on a conducting surface near the Van de Graaff generator, as the generator produces static electricity, the electrons could jump from the generator to the conducting surface and then to the paper, causing the paper to move or jump due to the repulsion of light charges.
Hair and the generator. If you place your hair near a Van de Graaff generator, it will create an electric field that causes your hair to stand on end. This happens because the electric field generated by the Van de Graaff generator creates a charge separation in your hair, with positive charge being attracted to the negative charge on the generator and negative charge being repelled. As a result, your hair will become charged with the same polarity as the generator, and this effect is known as electrostatic induction.
A Van de Graaff generator pulls electrons from the Earth, moves them along a belt, and stores them on the large sphere. These electrons repel each other and try to get as far away from each other as possible. Spreading out on the surface of the sphere, the Earth has lots of room for electrons to spread out upon, so electrons will take any available path back to the ground. The grounding rod is a smaller sphere attached by a wire to the Earth. It provides a convenient path for electrons to move to the ground, so if we bring the grounding rod close enough to the large sphere, the electrons rip through the air molecules in order to jump on the grounding rod, creating a spark and crackling noise.
Overall, Van de Graaff generator is a device that creates static electricity by accumulating charge on a large metal sphere or a belt that is constantly moving. The accumulated charge can be transferred to another objects, causing them to become charged as well. The generator has a wide range of scientific applications, including in particle accelerators, as a source of high voltage for scientific experiment and for educational purposes in demonstrating the principle of electrostatics.
For application, Van de Graaff generator is still used as accelerators to generate energetic particle and X-ray beams for nuclear research and nuclear medicine. Static electricity has practical applications like electrostatic precipitators, photocopiers, printers, and Van de Graaff generators.